Hello, welcome back. In the previous video, we learned how to construct one simple t-test or hypothesis test together, right? And we learned that we should be focusing first on the alternative hypothesis test, H1. And based on the sign that we have in the alternative hypothesis test, we should be constructing the null hypothesis, the status quo, right? So it is important to understand what the proposed system or the new system or the new claim is, and after we know what it is, and we go back to claim the status quo, right? You can just see that the fact that if you're playing a game with your opponent, you just need to know what opponent is actually doing, and then based on that, you take your position. So opponent's action would be considered as an alternative hypothesis test, alternative hypothesis, and your position is the status quo, right? That's just another way of looking at it if it makes things simpler. So this video is going to show you how you deal with hypothesis testing, right? What is the ultimate outcome, and hopefully we are going to be talking, about those things on a simple example. All right. So let's get started. So here we do have a department store manager, and he or she would like to determine that a new billing system will be cost effective only if the mean monthly account is more than $170 with this department. Okay. We do have customers, I think, shopping with this department store, and they would like to see that every customer come back here. The average of all the customer accounts is greater than $170. In that case, they are going to acquire this new accounting system. If not, they are going to go with the status quo, and we don't know really what the status quo is. It's not given in the question. Therefore, they do have a random sample of 400 monthly accounts, and they store this data in an Excel file given to you as well here. We do have different customer numbers here, 400 of them, and we do have their account balances in this specific month. Well, first of all, we really need to see what our status quo is and what the alternative hypothesis here. And then for that case, again, we start with the alternative hypothesis. Remember, alternative hypothesis should be the one that is challenging the status quo. If you carefully read the question again, it says that a department store manager determines that a new billing system will be cost effective only if the mean monthly account is more than $170. So the keyword here is more than, and you know that this is a claim or the alternative that is being proposed, right? Therefore, we should, it's a good hint, and then we should take it and then put it in the alternative statement, right? So here we say that our population mean or our average of monthly accounts, average of our entire customers is greater than 170. And in that case, we are going to go with this new accounting system, right? That's why we're claiming that we're going to install the new accounting information system. And what is just the other way around of this symbol is less than equal to, obviously, to cover the entire set of possibilities, and we put it in the null hypothesis, right, H0. So H0 here, status quo, keeping the old system. If we fail to reject H0, right, it means that we believe, our statistical test believes that our population average, in this case, our customers' average account balances is less than or equal to $170. We do have further information in the question. Says that the manager insists that the level of significance, or alpha, or probability of making a type 1 error, rejecting the null hypothesis when null hypothesis is true, should be taken as 5%. And this is given to us in the question, right? And it is in the control of the department manager. And says that, can we conclude that the new system will be cost effective? Well, how do we come to that conclusion? Remember, the department manager has a policy saying that it will be cost effective if the mean monthly account across all my customers is more than $170. The key here is, do we have that statistical evidence, right? Again, this is not giving you the data for The old system, I believe this is a demonstration phase, and they have adapted it for the demonstration purpose only. And they probably use it for a couple of weeks or maybe a month, and then they collected some data from the customers, and they are testing this new system. So when you have the old data, old versions data and new versions data, then that will be two sample hypothesis testing, right? And that's what we're going to learn in the next video. But here, sometimes you do have these, these circumstances. You just would like to make the effort to make your process better, but you only have the data for the new system, right? And you do have a mechanism to claim that your new system is successful, like in this question. Then it is also fine too, right? You can also do the statistical testing on these circumstances. So keep this in mind when you are working on your semester-long projects and maybe other projects as well. So you don't really need to have two different data sets to make a conclusion on what you're proposing. So sometimes you do run into these kind of situations in your continuous improvement projects. Okay, so let's get back to the question. So how do we handle that? We are given the data set, and we already constructed our alternative test, and then the null hypothesis test. How do we go with it from this point forward? Well, number one thing to do here is to make sure that the data is coming from a normal probability distribution, right? And to check that, Minitab is going to be our friend. Let's click on Minitab. First of all, we have to transfer all the data to Minitab. And I will do it in a quick way. I select my entire data set, and then starting from C1 column, I paste them here. Okay. And I change this worksheet name into accounts. If you go to stat and basic statistics and scroll down, we do have a nice menu item called Normality Test. It is very simple to do normality analysis or normality check in Minitab. And we are not going to go with customer numbers. We are interested in our accounts information here. You don't have to select anything else. You can go with Anderson-Darling test. There is not really a significant difference between these three tests. I always go with Anderson-Darling test. And I hit OK. And we look at the ultimate plot that it gives us. So this is the probability plot or QQ plot or normality test plot. Some people call them differently. Let me get this data out of the way. And what you see here is couple things actually, right? So let's focus on the data first. In good old days, we used to do pencil tests. Imagine that you have a thick pencil, and then you put this pencil on your screen. Does that thick pencil cover majority of the dots? If that's the case, then your data is coming from normal probability distribution. Or more specifically, you do have specific information here, right? And one of them is the p-value, right? P-value here is p-value is basically a percentage, right, between 0 and 1. And if it is greater than 0.05, which is the default level of significance, what we do here, we do not have statistical good amount of information or evidence to reject the null hypothesis. And the null hypothesis here in this case is the data is coming from the normal probability distribution. Well, that is a long way of coming to conclusion, but when you see a high p-value, you reject the null you fail to reject the null hypothesis. In this case, our null hypothesis is data is coming from normal probability distribution. So we conclude that the data is actually coming from normal probability distribution. One more time, if the p-value is greater than 0.05 in this case, right? This is the level of significance value for this normal probability test. Then the data is coming from normal probability distribution. If this p-value were to be very small number, smaller than 0.05, then we would reject the fact that this data is coming from normal probability distribution. All right. I hope this is clear. And this would show you how to do normality check in Minitab. All right, what is the next step? Well, the next step is to do hypothesis testing, right? And hypothesis testing can be found again under the stats menu. You go to I believe basic statistics. Here it says one sample z-test and one sample t-test. Again, when do we use one sample z-test? When we do know the population standard deviation. In this case, nothing is given to us in the question. So I click on one sample t-test and it says, all right, let me click here. It says one or more samples, each in a column. I do have only one sample. I don't have any summarized data, and my observations are in a single column, and those are the counts, right? And I say, yes, please perform hypothesis test. It says, what is your hypothesized mean? It is actually asking me what is my constant that I am using on my hypothesis test. In this case, this is 170, right? We are going to tell Minitab that the alternative hypothesis is greater than, right? So we haven't done that yet, but let me enter 170 here. And if you go to options, the default selection is not equals to, all right? And the confidence level, again, this is 1 minus alpha. What did our department manager told us? So the department manager told us to use alpha equals to 0.05, and 1 minus 0.05 is actually 0.95. I'm not going to change it, therefore it's going to stay like this. But I'm going to change this one because it suggests that I should be using not equals to in my alternative hypothesis, and my alternative hypothesis should be greater than. All right, therefore I change it to greater than. And okay, let's go to graphs option. Yeah, I'd like to see histogram, individual value plot, and box plot options. I selected them all and done. All right, Minitab gives me good amount of information. Let's focus on the first one that it gives me. It basically tells me that I got 40 different customer information. The mean of these account balances in the sample is $178. This is the standard deviation. This is the standard error of the mean. It doesn't really matter. What matters here is this one and the p-value that we receive here. Let me talk about this 95% lower bound for the mu. So this is the confidence interval lower bound, and it is telling us that if I have 100 different samples like this one that I have, all right, let's assume that if I had 100 different data sets like this one, 95% of them would give me a lower bound of $172 as the average customer balance account. Well, this is a powerful information because it basically tells me that, hey, your lower bound on your account balances is $172. This is already larger than the claimed value of 170. And my conclusion would be here immediately reject the null hypothesis. Well, my null hypothesis is my mu is less than or equal to 170. I already saw that the lower bound of my confidence interval is giving me $172. The other way to have this conclusion is to look at the p-value, and this is probably going to be a lot easier compared to this one. Again, when your p-value is less than your level of significance value, which is alpha, and that is 0.05, then we reject the null hypothesis. And again, you see Minitab already portrayed you the null hypothesis and alternative hypothesis here correctly. Well, one thing to realize here, Minitab has mu equals to 170. This would indicate that actually mu is less than or equal to 170, all right? Some textbooks also do this notation, but we will be sticking to the notation that I presented to you in the slides. Long story short, the p-value of 0.01 is less than my 0.05 level of significance. Therefore, my conclusion is to reject the null hypothesis in favor of the alternative one. All right. In this case, we are suggesting that yes, we should call it the mu accounting information system because it is proven to be effective. Right? Why not we stick to the original? We'll stick to the status quo if you know that we do have a better alternative. That is how you can use hypothesis testing to make managerial decisions at work. So Minitab gives us also, remember I checked all these different cool stuff right there in the graph options. It gives me the histogram of my account balances. Looks like it is fitting into bell curve, which is a good sign that it's coming from, the data is coming from normal power distribution. And it is actually showing me the dot plot, the individual value plots in terms of plots. Well, those are all account balance information in plots, right? And it is actually telling me that my 95% lower bound here and then here is actually starting from 172. 172. If you look at the this blue line carefully, you see that, and H0 here is actually indicating 170. And this is the box plot if you're ever going to use that. All right. In summary, how you do this analysis in Minitab, you go to stat, you go to basic statistics, and click on one sample t-test, and you select your, the sample observation. This time it is under C2 column. We click on perform hypothesis testing. We entered the hypothesized value here. And from the options, we selected the correct alternative hypothesis sign. In our case, it was greater than hypothesized mean. And we selected 1 minus alpha. Alpha here is 0.05 given in the question. And then we entered 95% here. And then we hit OK to get the results of our hypothesis test. If we do not really worry about the confidence interval decisions, you just focus on the p-value here. And if your p-value, again, is lower than your alpha value, then you reject the null hypothesis in favor of the alternative one. Okay, that was our conclusion. And these are actually, I copied and pasted the results here. Therefore, the new alternative accounting information system is cost effective, and we statistically prove that it is going to give us better results. So again, when you are doing hypothesis testing, you get the p-value out of your hypothesis test. If your p-value is less than your alpha value, alpha is the level of significance or probability of making type 1 error, right? Then you reject the null hypothesis in favor of the alternative one. This is very important. And please listen to the boss baby here on the right. If the p-value is low, then the current status quo must go, and we have to adapt to the new system. This is how you handle one sample hypothesis testing analysis. In the next video, I'm going to show you how you do it when you have two different samples information. Let me give you some time to ponder.